This is the video lesson for Math 3, Lesson 3, which is factoring trinomials where a is greater than 1. In this video, we're going to be learning how to factor trinomials where a is greater than 1. So an example of that would be if I have 3x squared plus 22x plus 24. So this is a trinomial because it has 3 terms. We talked in the previous video degree and leading coefficient. So this one actually has a leading coefficient of 3 and a degree of 2. So our a value is our leading coefficient, and in this case we have a value that's greater than 1. So these are the steps we're going to use, and we're going to walk through this example on the next slide. But basically, we're going to have it in this ax squared plus bx plus c form. And it's very similar to how we would factor when a equals 1. The big piece that's different is we're going to end up using this leading coefficient to help us factor. And we'll walk through these steps when we do the problem, but you can kind of see that they're listed at the top of your packet for a reference. All right, so this is the example that we just saw a moment ago, and we're going to factor this and we have our a value greater than 1. The first thing is we're going to check that we have this in descending order, which we do. So our x squared is listed first, then our b value is 22. We have our constant listed at the end. And the first step we're going to do is multiply our a times our c value. So if I do, in this case, 3 times 24, I'm going to get 72. And what I'm going to look for now are factors of 72 that add up to 22. So we're still adding up to that b value. All right, so the only thing that's different is we multiply our a times our c, and essentially we can even be doing that when a is equal to 1. Just 1 doesn't really do anything to change the problem. So we're going to look for numbers that multiply to give us 72 and add to 22. We can use our calculator if we like. We can make a table and list our factors. So if it multiplies to give us a positive, we know the signs have to be the same. And if it adds to a positive, we know that they both are going to be positive, right? So those are kind of some characteristics of our factors we're going to have. The other thing that we maybe want to write, I'm going to write here maybe LC. Our leading coefficient is 3. So we're going to end up using that 3 later. We multiplied 24 times 3. We're going to use that to help get our factors, and then we end up having to divide that out later. All right, and this is like one of many, many ways that we can actually factor. So if I multiply this out, I got 1 times 72, 2 times 36, 3 times 24, 4 times 18, and if I keep going down here, I can list all of my factors, but I'm looking for a pair that adds to 22, and actually I find that it's actually 4 plus 18 will give me 22. All right. Now, up to this part, nothing's really too different than what we saw with factoring when a is 1. Again, the big difference is we're going to use this leading coefficient. If we multiply it in, we got to divide it out. So, and this is one of a whole bunch of different ways to factor. I'm going to write this so it's x plus 4. And I'm purposely kind of putting a little space under that 4. And x plus 18. The difference is I'm going to divide by my leading coefficient. So I'm going to divide each of those factors by my leading coefficient. All right, so that's the only thing that's a little different. So I have a leading coefficient of 3. I multiplied 24 by 3. I'm dividing out and seeing if 3 goes into any of those factors. So when I rewrite this, I have x plus 4/3. 4 over 3 doesn't simplify, so I'm going to leave it like that for right now. And then 18 over 3 actually simplifies to 6. I could actually simplify that fraction. All right, so we have this answer that looks, x plus 4/3, x plus 6. If the question is do they want it factored, we don't want to leave fractions in our problem. We want integers. So we're going to take this 3, and actually it's like you're almost multiplying through by 3. I'm actually just going to rewrite it as 3x plus 4 x plus 6. I don't have to rewrite the x plus 6. And really what I did here, it's kind of like you're multiplying 3 by 3 to get rid of that fraction if you like, because it ends up doing the same thing. If we solve an equation later, we actually don't even have to do that step. But basically what we did is the same thing we did where a is 1, divide the factors by the leading coefficient, and then from there, see if it simplifies, and if there's a fraction, we rewrite it so the denominator is now listed in the front of that x. And this would be our final answer. I'm going to do the same exact thing with question number 2. So question number 2, I see it's in descending order already. I'm going to do factors of 2 times 3, which is 6, that add up to negative 5. So numbers that multiply to 6 but add to negative 5. And then I'm also going to write over here that my leading coefficient is a positive 2. So if I multiply through by that 2, I got to divide out by that 2. If it adds up to a 6, the signs, or multiplies to 6, the signs are going to be the same. And in this case, if it adds to a negative, they're both going to be negative numbers. If we list it out, I have here 1 times 6, 2 times 3. They're both going to have to be negative. And then my pair that ends up working is negative 2 plus negative 3. And then we're just going to then do our last step where we write our or not our very last step, but we're going to write our factors in here. But then I have to divide by my leading coefficient. So I have to divide by 2. So I'm going to divide by 2. And you're usually going to find that it goes into at least one of them, right? So I have here x minus 2 over 2 is 1. This is x minus 3 halves. And since I don't want to leave a fraction there, I'm going to move this 2 out of the denominator. And then I'm going to get 2x minus 3. And this would be my final factored answer. For these last two examples, again, same thing, but just so you can kind of see like other things that might pop up with the problem, but same concept. So I have to factor this. My a value is bigger than 1. So I'm still going to do a times c. So 6 times negative 14. And that gives me negative 84. And we want them to add up to negative 17. And again, my leading coefficient, I'm going to write off here to the side, is going to be 6, right? That's my number in front. So when I list out my factors, again, I can kind of, if I make a list, your calculator, and we'll practice in class how you can use your calculator if you like, when you're making your list. So we can go, if you're not sure, I usually just say start numerical order. We know that it multiplies to a negative, so the signs are different. And it adds to a negative, so the larger number is going to be negative. So if we write this out here, we have 3 and 24, 4 and 18. My larger column is going to be negative. And actually, I end up getting the, 4 and 21. And we actually end up getting our pair being right here. So 4 plus negative 21 is 17. Okay, we're now going to go ahead and do the same thing we did in the last part. So I'm going to write x plus 4, x minus 21, and then we're going to divide by our leading coefficient. And this is one where we have a little bit of simplifying actually that happens in both fractions, which is fine. So 4 over 6 ends up being 2/3. Negative 21 over 6, they're both divisible by 3, so we end up getting 7 halves. And so this is a case where 6 actually part of those factors went into each of them. And now I'm just going to rewrite it. So I want to move the 3. I want to move the 2. So I'm going to get 3x plus 2 and 2x minus 7. And this would be our final answer. And then finally for this last problem, same thing. We're going to do 2 times negative 5, which is negative 10. And it adds to a negative 9. So factors that multiply to negative 10, but add to negative 9. And then our leading coefficient is going to be a 2. Okay, so when we list this out, I know the signs have to be different because it's negative, and the larger number is going to be negative because it's a negative 9. So if I list out my factors, it actually works out that 1 times negative 10 is negative 10, and 1 plus negative 10 is negative 9. So this would be my factor pair. And then we're going to go ahead and factor it out. So x, I have a 10 and a 1. I'm going to divide by my leading coefficient. So this would be x minus 5, x plus 1/2, and then the 2 that's in the denominator, I got to move. So x minus 5, and then 2x plus 1, and this would be our final answer. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.